Software testing is like being a detective. Just as a detective meticulously examines clues to solve a mystery, a software tester carefully analyzes the software to uncover hidden issues. This process is crucial in ensuring the software's reliability and performance. We find problems in software. These problems, often referred to as bugs, can range from minor glitches to significant errors that could affect the software's functionality. Identifying and fixing these bugs is essential to deliver a smooth user experience. This makes sure the software is good before it is released to users. By thoroughly testing the software, we ensure that it meets the required standards and performs as expected. This step is vital to maintain the software's quality and user satisfaction. There are two main ways to test software: manual testing and automation testing. Each method has its own advantages and is used based on the specific requirements of the project. Manual testing is done by a human. In this method, a tester manually interacts with the software, performing various actions to identify any issues. This approach allows for a more intuitive and user-centric evaluation of the software. The tester interacts with the software like a user would. They navigate through the application, perform tasks, and observe the software's behavior to detect any anomalies or bugs. They look for bugs and other problems. Once identified, these issues are documented and reported to the development team for resolution. This process helps in refining the software and enhancing its overall quality. Automation testing uses tools to run tests automatically. These tools can execute a large number of tests in a short period, making the testing process more efficient and comprehensive. This is faster and can find different types of problems. Automation testing is particularly useful for repetitive tasks and regression testing, where the same tests need to be run multiple times. It's important to prepare for job interviews in software testing. Understanding the fundamentals of both manual and automation testing can give you an edge in the job market. We will look at some common interview questions. These questions often cover various aspects of software testing, including methodologies, tools, and best practices. Being well prepared can significantly increase your chances of success in landing a job in this field. Exploratory testing is an important part of software testing. In exploratory testing, testers do not follow predefined steps. They use their knowledge and intuition to find bugs. It is like exploring a new place. Testers learn about the software as they test it. They design and execute tests at the same time. This helps them to find bugs that might be missed by other testing methods. Exploratory testing is useful for finding usability problems. It also helps to find problems that are difficult to predict. Regression testing ensures that changes to software do not introduce new problems. It involves retesting the software after modifications. These changes could be bug fixes, new features, or other updates. The goal of regression testing is to verify that the existing functionality still works as expected. This helps to maintain the stability and reliability of the software. Regression testing is often automated to save time and effort. It is an essential part of the software development lifecycle. Prioritizing test cases is important because we cannot test everything. We need to focus on the most important tests. This helps to ensure that we find the most critical bugs. There are several factors to consider when prioritizing test cases. One important factor is the impact of a bug. We should prioritize tests that cover high-risk areas. Another factor is the frequency of use. We should prioritize tests that cover features that are used frequently by users. Test metrics help us to measure the effectiveness of our testing. They provide insights into the quality of the software. There are many different test metrics that we can use. One important metric is defect density. This measures the number of defects found per line of code. A lower defect density generally indicates higher software quality. Another important metric is test execution time. This measures how long it takes to run all of our tests. User acceptance testing, or UAT, is the final stage of testing. In UAT, real users test the software to make sure it meets their needs. This is important because users are the ones who will be using the software on a daily basis. UAT helps to ensure that the software is usable and meets the requirements. It is typically performed in a real-world environment. UAT is essential for the success of any software project. Software testing is typically divided into different levels. Each level focuses on a different aspect of the software. The four main levels of testing are unit testing, integration testing, system testing, and acceptance testing. Unit testing tests individual components of the software in isolation. Integration testing tests how these components work together. System testing tests the entire system as a whole. Acceptance testing, as we discussed, focuses on user needs and acceptance. Boundary value analysis is a test technique that focuses on the boundaries of input values. This method is crucial in identifying potential defects that might not be evident in the middle ranges of input values. By concentrating on the edges, testers can uncover issues that could cause significant problems in real-world scenarios. This technique is based on the idea that defects are more likely to occur at the boundaries of input domains. When software is developed, the edges of input ranges are often where unexpected behaviors can manifest. These boundary conditions are critical because they represent the limits of what the software can handle. For example, if a program accepts input values between 1 and 10, we would want to test the program with values 1, 2, 9, and 10. These values are at the edges of the acceptable range and are more likely to reveal any weaknesses in the software's handling of input. Boundary value analysis helps to ensure that the software handles edge cases correctly. By rigorously testing these boundary values, we can be more confident that the software will perform reliably under a variety of conditions. This is especially important in critical applications where failure at the boundaries could lead to significant issues. It is a simple but effective test technique. Despite its simplicity, boundary value analysis can uncover complex issues that might otherwise go unnoticed. This makes it an invaluable tool in the software tester's toolkit. It can be applied to a wide range of software applications. Whether it's a web application, a mobile app, or a complex enterprise system, boundary value analysis can help ensure that the software performs as expected. By incorporating this technique into the testing process, developers and testers can improve the overall quality and reliability of their software products. Functional testing ensures that the software functions as expected. It focuses on the behavior of the software. Examples of functional testing include testing that a login button works correctly or that a shopping cart calculates the total price correctly. Non-functional testing focuses on the quality attributes of the software. These attributes are not directly related to the functionality of the software. Examples include performance, security, and usability. A defect or bug goes through a life cycle from the moment it's found. This journey is crucial in the software development process, ensuring that the final product is as flawless as possible. The life cycle of a defect begins with its discovery and continues until it's resolved. Understanding this life cycle helps to manage and track defects effectively, ensuring that no issue is overlooked. The defect life cycle typically includes several stages, each playing a vital role in the resolution process. A defect is reported for the first time. This is the initial stage where a tester or user identifies an issue and logs it into the defect tracking system. Detailed information about the defect, such as steps to reproduce, severity, and screenshots, is provided to help the development team understand the problem. Assigned. The defect is assigned to a developer for fixing. The project manager or team lead reviews the reported defect and assigns it to a developer who has the expertise to address the issue. This stage ensures that the defect is in the right hands for resolution. Open. The developer is working on fixing the defect. During this stage, the developer investigates the root cause of the defect, writes the necessary code to fix it, and performs initial testing to ensure the fix works as intended. Fixed. The developer has fixed the defect. Once the developer is confident that the issue has been resolved, they mark the defect as fixed in the tracking system. This indicates that the defect is ready for further testing. Verified. A tester checks if the fix worked. The QA team retests the defect to ensure that the fix is effective and that it hasn't introduced any new issues. This stage is critical to maintaining the quality and stability of the software. Closed. The defect is considered resolved. Once the tester verifies that the defect has been fixed and no further issues are found, the defect is marked as closed. This final stage signifies that the defect has been successfully addressed and the software is one step closer to being error-free. Test deliverables are the documents and artifacts produced during the testing process. These deliverables provide valuable information about the quality of the software. They also help to track the progress of testing activities. Some common test deliverables include test plan, outlines the testing strategy and approach, test cases, detailed steps for executing tests, test data, data used for testing, defect reports, documentation of found defects, test summary report, summarizes the testing results,